probability and normal distributions. So here we're going to use our knowledge of percentage of scores in a normal distribution that lie within a z-score to work out probabilities. So we're just going to draw up another normal distribution. And we know that's where our mean, median, and mode is, and that's where our z-score of 0 is. And let's look at our z-score of -1 and our z-score of 1. And we know inside here is 68% of all scores. 68 can also be represented by 0.68 as a decimal. And in terms of probabilities, to know where probabilities of scores are going to lie, we can write it as something like this. We can say that one standard deviation away from the mean is the probability that the z-score will be between -1 and 1. And we know that 68% of scores lie in there, or 0.68. So for a probability that it's going to lie between -2 and 2, that's going to be 0.95, because we know 95% of scores lie within there. And for a probability between -3 and 3, we know that's going to be 0.997, because it's 99.7%. It's important to know that here we're looking at the area under the curve. So for this one, this area here represents 0.68. It doesn't have any units, but you can think about it as being an area. And even though the curve doesn't close, the area of the whole curve is represented with a 1, because that represents all probability. So the area under every bit of the curve is 1. Okay. Now, it's important to note that, so let's draw another diagram. So let's have a look at, we're going to have a look at the probability that the z-score is going to be less than 0 is actually a half, because that's half of the scores. You can think about your normal distribution where the z-score is 0 right in the middle, and if it's going to be less than 0, that's all over here, so that's half of 1, which is just a half. Now it's very important that the z-score less than or equal to 0 is also a half, because there's no area about this line, so we can include that line as well. So we can include 0 and it's still going to be a half. So that gives us a special property that the probability that a z-score is less than any amount, let's say c for some constant, is the same that the probability of that z-score will be less than or equal to that amount. So we can easily substitute that out. And this means if we have the probability that a z-score is less than some amount c, plus the probability that a z-score is greater than some amount c, that's going to give us 1. And we can show that with another curve. So let's say the amount c is over here. The probability that's less than c is all this side, and the probability that it's greater than c is all this side, and this line has no area, so we've covered the whole curve, and that's why when we add them together we get 1. We can rearrange this by minusing this term from both sides, and that's going to give us the property that the probability that we're going to have a z-score less than c is equal to 1 minus the probability that a z-score is greater than c. And we're going to use all these in some examples. So what's the probability that a z-score lies in between 0 and 1? So when they're nice whole numbers, we can draw our normal distribution to help us out if we have to. So that's a z-score of 0. And we want to know what's the probability it's going to be between 0 and 1. So we know 1 is just over there because it's positive. And minus 1 would be here. And altogether that's 68%, so half of it's 34%. So that means this is going to be 0.34 when we change it from a percentage to a whole number. Alright, let's look at a trickier one. What's the probability that a z-score is going to be less than 2? Well, yeah, this is a bit trickier if we think about it. So here we've got our z-score of 0. And our z-score of 2 might be out here. Now, this seems like all this area on this side looks like it goes forever because it doesn't close off. But we can use the fact that we know that the probability that a z-score of less than 0 is always a half, or greater than 0 is a half. So we know everything on this side equals a half. So we can rewrite this, that this is going to be the probability that the z-score is less than 0 plus the probability that it's going to be between 0 and 2. And we can work this out. Because we know the probability that the z-score is less than 0, well that's half of it, plus between 0 and 2, if you remember from before, let's say z is equal to 1 is there, that's 34%. And in between, well we know this is the whole between minus 2 and 2 is 95%. So in here, that's half of 95, which is 47.5%. So we can add on 0.475. And that's going to give us 0.975 for there. Now, what's the probability that z is going to be greater than 2? Well, don't forget about our property that if we have the probability that z is less than some number plus the probability that the z-score is greater than some number, it equals 1. And we just worked out the probability that the z-score was going to be less than 2, because that's what we did up here. That was 0.975. So this must be 1 minus the probability that the z-score will be less than 2. So we get 1 minus our previous answer of 0.975, and that's going to give us 0.025. Now, if z's not a whole number, you're going to have to get the value from a table. So you might have a table that looks something like this, where it's got z and 0.0, 0.1, 0.2, 0.3, and so on. Then up here you'll have 0.00, 0.01, 0.02, 0.03. And you'll have various values for the probability in here. So you might have 0.50000 in there. Down here, you might have 0.62930, or you do have that. Now, what do these values in the table mean? So let's look at this one in particular. So that one there, let's draw up so it's lining up with this one and this one. All you have to do is add those two values together, so 0.3 plus 0.03, and that's going to give you 0.33. And the values in the table always give you the probability that z is going to be less than that value. So 0.33 So the probability that z is going to be less than 0.33 is 0.62930. And just representing that on the normal distribution, we've got here, we've got our normal distribution. That's our z-score of 0. Just going to do a wide one. That's our z-score of 1. Now 0.33 would be about there. And that 0.62930, just a different colour, is all this area here. So you can see it should be bigger than a half, which it is, and that's how we get that value.